All right, so get this. We're diving into some pretty wild stuff today.
Oh, yeah.
Remember all that hype about AI making art? Well, it turns out the tech behind it.
Yeah, those diffusion models.
Exactly. Those diffusion models are being used to predict the weather now.
Whoa, really?
Yeah, no fancy satellite pictures or anything, just pure number crunching,
Ah.
kind of shaking things up in meteorology.
Yeah, I bet that's pretty unexpected.
Definitely. So what's the name of this weather model?
It's called Gencast.
Gencast.
Yeah, it was developed by Google DeepMind.
Okay.
And it's really turning heads because it's outperforming some of the most sophisticated forecasting systems we have.
Really?
Yeah, even predicting, like, extreme events with crazy accuracy.
Okay, I am intrigued. So how does it actually work? I get the image thing, adding the noise and reversing it, but
Right.
this is weather we're talking about, not making pictures.
Exactly, and that's what's so interesting about it. Gencast doesn't use images at all.
What?
Nope. Instead, it's trained on this massive data set. It's called the ECMWF ERA5 archive.
The ECMWF what now?
ECMWF ERA5 archive.
Mm.
It's basically this gigantic record of the Earth's weather going back like 40 years.
40 years.
Yeah, like measurements of temperature, wind speed, pressure, all that stuff.
So it's like Gencast is reading a 40-year-long weather journal for the whole planet.
That's a great way to put it.
Mm.
And just like those diffusion models learn to make images from noise, Gencast has learned to recognize these intricate patterns and relationships in all those numbers.
Okay, so it's looking for patterns in decades of weather data.
Yeah.
But how does that actually become like a weather forecast?
Well, instead of like recreating an image, it generates sequences of numbers that represent future weather scenarios.
Okay.
And here's the really cool part.
Yeah.
It doesn't just give you a single prediction. It produces what are called ensembles.
Ensemble. So it's like hedging its bets, giving us a range of possibilities.
Exactly. It's acknowledging that weather is inherently uncertain.
Mm-hmm.
So instead of saying, it'll be 25 degrees tomorrow,
Right.
it'll say there's a 60% chance of temperatures between 23 and 27 degrees.
Well, that makes a lot more sense. It's like when a weather forecaster says there's a chance of rain rather than it will definitely rain.
Right.
So how do those Gencast ensembles stack up against the old school forecasting methods?
Well, it's not just an improvement. It's a major leap forward. When you compare it to the European Center for Medium-Range Weather Forecasts, ENS.
That's a mouthful.
Yeah, ECMWF ENS, which is like the leading forecasting system right now.
Okay.
Gencast actually outperforms it on most predictions up to 15 days out.
15 days. That's impressive. Most forecasts I see get really iffy after a week.
And here's where it gets even cooler.
Okay.
Gencast is really good at forecasting extreme weather,
Really?
like heat waves, high winds, even the paths of tropical cyclones like hurricanes and typhoons.
Hold on. More accurate hurricane predictions.
Yeah.
That would be huge for coastal communities.
Absolutely. And think about what that means for other things, too, like agriculture, aviation, renewable energy. Better forecasts mean better planning, which leads to more safety, better efficiency, and resource management.
And all of this from a model that doesn't even look at pictures.
It's pretty remarkable, right? It shows that sometimes the best solutions come from looking at things from a completely different angle.
I'm starting to see why people are excited about this. But how practical is it? I mean, the old way of forecasting uses these massive supercomputers running for hours.
Right.
What kind of computer does Gencast need?
Well, that's another area where Gencast shines.
Yeah.
It can generate a 15-day forecast in just 8 minutes, and it all runs on a single Google Cloud TPU v5.
Wait, hold on. What's a TPU v5?
Oh, right. TPU stands for Tensor Processing Unit. It's a special piece of hardware Google made specifically for machine learning.
Okay.
The V5 is the 5th generation of that technology, and it's super powerful and efficient.
So not your average computer.
Definitely not. These TPUs are designed to handle the crazy calculations involved in training and running these massive AI models like Gencast.
So we've got this incredibly accurate and efficient AI model running on specialized hardware. Sounds like a pretty big accomplishment. What's next for Gencast? What's Google DeepMind doing with this technology?
Well, this is where it gets really exciting. They've decided to make Gencast's code and weights public.
Wait, they're making it open source.
Yeah.
That's huge. What does that mean for the scientific community?
It means that researchers everywhere now have access to this cutting-edge technology. They can study how it works, experiment with it, and even use it to build even more advanced forecasting models.
Wow. So instead of keeping it a secret, they're giving it to the world.
Yep. It shows how committed they are to open science and the idea that collaboration is key to unlocking AI's potential to help humanity.
This is blowing my mind. I mean, who would have thought that the same tech used to make those AI images could also predict the weather so accurately?
It really shows how different fields can come together and inspire each other. And the fact that it's open source, that changes everything. It opens up so many possibilities for future research and development.
So what kind of possibilities are we talking about? What could happen now that researchers around the world have this technology?
Well, for one other, research groups can now take Gencast and train it on different data sets, maybe focusing on specific regions or types of weather.
So we could have models for predicting monsoons in India or blizzards in the Northeast.
Exactly. And since Gencast is so efficient, researchers could even run it on less powerful computers, making it more accessible to more scientists around the world.
That's a great point. Giving more people access to these tools could really speed up progress on a global scale.
Absolutely. And it's not just about focusing on different places. Remember how we talked about Gencast creating those ensembles of possible weather scenarios?
Yes, the hedging its bets approach.
Right. Well, there's a lot of room for improvement in how we interpret and communicate those ensembles to the people who need to make decisions.
So it's not just about making the predictions better, but also making them more understandable and useful?
Exactly. Imagine a tool that could visualize those different weather scenarios, showing the possible effects on a region or a system.
Yeah, that would be amazing for things like disaster preparedness, urban planning, even resource management.
Yeah.
It's not just about knowing a hurricane might hit. It's about understanding what could happen and preparing for it.
Precisely. And we're just scratching the surface here. The open source release of Gencast could lead to a whole bunch of new innovations in weather forecasting and climate science impacting countless other fields.
It's like we've been given this powerful new way to understand the weather, and with it, the ability to predict and prepare for the future like never before.
It's a powerful reminder that we live in an age of incredible technology. And when AI is used thoughtfully and ethically, it has the potential to solve some of our biggest challenges.
This is a lot to take in. We've covered a lot in a short amount of time. But before we finish part one of our deep dive into Gencast and these amazing diffusion models, there's one question I want to ask you.
Okay, I'm listening.
We keep talking about these weights that are released with the code. What do they actually look like? Is it like a massive spreadsheet of numbers?
That's a great question. It really gets to the core of how these models learn and make predictions. Yeah, you're right. They are a huge collection of numbers, but they're not just random.
Oh, okay.
They're organized in a very specific way that basically defines the structure and the function of the model.
Okay.
Think of it like a complex network, like a brain, with all these interconnected nodes.
Okay.
Each connection between those nodes has a weight assigned to it that represents how strong that connection is.
So instead of just a jumbled mess of numbers, it's more like a highly organized network where each weight has a specific job.
Exactly. And those weights are constantly being adjusted during the training process as the model learns from all that data.
Oh,
It's
yeah.
kind of like fine-tuning a musical instrument.
Okay.
You adjust the tension of each string till it sounds just right.
So when they release the weights, they're sharing that tuned version of Gencast, all the knowledge it's gained from analyzing all that weather data.
Exactly. That's why it's so valuable to other researchers.
Yeah.
They can take those weights and use them as a starting point for their own experiments without having to go through the hassle of training the model from scratch.
It's like giving someone a head start in a race.
Exactly.
They don't have to train for months to reach the starting line. They can just jump in and start running.
Perfect analogy.
Yeah.
And because it's open source, any improvements or discoveries made using those weights can be shared back with the community.
Oh, it's excellent.
So it speeds up progress even more.
This whole collaborative thing with open science is really powerful.
It really is. It creates this environment of shared learning and really accelerates discoveries, especially in a field as complex and important as weather forecasting.
Yeah, for sure.
The more people working on these problems, the better prepared we'll be to understand and adapt to climate change.
It's like we've all been given this powerful new tool.
Right.
And now we're all working together to figure out the best way to use it.
That's a great way to think about it. And with Gencast, that tool has the potential to really change things.
So where do we go from here? What are some of the directions that research could take now that Gencast is out there?
Well, there are a lot of exciting possibilities.
Yeah.
We already mentioned that researchers could train Gencast on different data sets
Right.
to focus on specific regions or types of weather events.
So maybe a team in Australia could focus on predicting bushfires, or a group in the Caribbean could specialize in hurricane forecasting.
Exactly. And because Gencast is so efficient, it creates opportunities for researchers who may not have those huge supercomputers.
So it's making this cutting-edge technology available to more scientists.
Exactly. And remember those ensembles we talked about?
You mean the multiple weather scenarios Gencast creates?
Yes. The idea that it's not about finding one definitive answer, but understanding a range of possibilities.
Yeah.
Well, there's a lot of potential for research on how to best interpret and communicate those ensembles to the people making decisions.
So making the predictions more useful and understandable.
Exactly. Like imagine a tool that could show those different weather scenarios and how they might impact a specific region or infrastructure.
That would be incredibly helpful for things like disaster preparedness, resource management, urban planning, so many things.
Absolutely. It's about turning those complex probabilities into something tangible that people can use to make better decisions.
This is amazing. I'm starting to understand just how powerful these diffusion models can be. It's not just about creating cool images anymore.
It's about solving real-world problems.
Yeah, and understanding these complex systems and building a better future.
Exactly. That's the beauty of AI. When it's used ethically and thoughtfully, it can unlock solutions to some of our toughest challenges. And who knows what other surprises await us as we explore these diffusion models further.
It feels like we're at the edge of something brand new, and the possibilities are endless. But let's come back to the present for a second.
Okay, sounds good. What's on your mind?
We've talked about the benefits of Gencast, the open source release, the ethical stuff, but I want to get into the details a bit. You mentioned earlier that it's really good at predicting extreme weather events.
Yes, it really is.
So what makes it so good at that? Is it just because of the amount of data it's trained on?
That's a great question.
Yeah.
And it gets to the heart of why Gencast is such a big step forward for weather forecasting.
Ah.
Well, it's a few things, really. The amount of data is definitely important.
Right.
Gencast has been trained on 40 years of global weather data.
Yeah.
So it's seen a ton of extreme events, but it's not just about how much data there is.
Right.
It's about how Gencast actually learns from it.
So it's not just a brute force thing. There's something more going on.
Exactly. Gencast uses those diffusion models, which are really good at finding complex patterns and relationships in data.
Right.
Remember, these models learn by reversing the process of adding noise until everything's just chaos.
Yeah.
And in doing that, they learn to see these subtle connections that other methods might miss.
So by figuring out how to bring order back from all that chaos, Gencast has learned what drives these extreme events.
That's a great way to put it. And that deep understanding helps it make better predictions, even for those rare or unpredictable events.
That makes sense.
Yeah.
It's like someone who studied tons of battles and history will be better at predicting what'll happen in a future conflict.
I like that analogy. Experience and exposure to different situations really matter, and Gencast has had a lot of both.
Yeah.
But there's another thing that helps it predict extreme events.
Okay.
Remember those ensembles, those different possible scenarios it creates?
Yeah, the hedging its bets thing.
Right.
Or,
Well, that's especially helpful with extreme events because they're like outliers.
yeah.
They're outside the normal weather patterns.
Right.
Those traditional forecasting methods, they focus on just the most likely thing happening.
Yeah.
So they might be good at predicting a regular summer day,
Mm,
but something like a crazy heat wave, not so much.
I see. So they might miss the really unusual stuff.
It's exactly.
Yeah.
But Gencast, because it makes multiple scenarios, is more likely to see those outliers, even if they're not the most likely outcome.
So it's like casting a wider net. You're more likely to catch something strange if you're not just looking for the most common fish.
Uh-huh. Yeah, exactly. And that's why Gencast's ensembles are so important for extreme weather.
Mm.
It's not just about being right. It's about understanding all the possibilities, which helps people make better decisions when things are uncertain.
This has been amazing. I'm really starting to understand the power of these diffusion models. They can do so much more than just make cool images.
It really is a fascinating time for this technology.
Mm.
We're seeing these models being used to solve real-world problems in such creative ways.
Well, I think that about wraps up our deep dive into Gencast and the world of diffusion models. We've seen how this technology is changing things from AI art to weather forecasting.
And thanks to those open source projects like the one from Google DeepMind, the future of this field is wide open. Who knows what other amazing applications we'll see?
It really makes you wonder. And that's what I love about exploring these topics. It reminds us that we're always discovering new things and there's always something new to learn. Until next time, keep exploring, keep asking questions, and keep diving deep into the world around us.